Hello everyone, welcome back to our channel. My name is Anjali Mishra. Students, in the last video we were talking about formation of different compounds where we have seen that how sodium chloride is formed, how magnesium chloride is formed. Moving on to the next segment, let's talk about ionic compounds, which are also called as electrovalent compounds. So, students, here the definition part says that ionic compounds are those compounds which are formed by transfer of electrons from a metal to a non-metal. यानी कि just now we have seen that how sodium chloride is formed or how magnesium chloride is formed. So sodium is a metal while magnesium is also a metal, and in both the cases we have chlorine which is a non-metal, and here both the elements were acquiring stability by gaining and losing electrons, therefore by transfer of electrons. So both sodium chloride and magnesium chloride are examples of ionic compound, or we can say electrovalent compound. So, some properties of ionic compounds are they are formed by the transfer of electrons and are made up of ions. For example, sodium chloride is made up of sodium and chloride ions. Magnesium chloride is made up of magnesium ions and two chloride ions. So that is how we can say that these ionic compounds are made up of ions. Then these are crystalline solids, means that both sodium chloride and magnesium chloride structure wise will form crystalline lattice. So that is how we can say that these are crystalline solids. Next statement says both sodium chloride as well as magnesium chloride has got high melting and high boiling point. So again, remember, high melting point means, or how to define melting and boiling point, we can say it's the temperature at which a material starts boiling. For example, if we say or if we talk about what is the boiling point of water, we can say it's around 100 degrees Celsius. Talking about melting point, we can say the temperature at which a substance starts melting is called its melting point. And what is the melting point of water? Remember, boiling point is 100 degrees Celsius while melting point is 0 degrees Celsius. So this was the third property of ionic compounds. Next statement or next property says that these ionic compounds or electrovalent compounds are soluble in water but insoluble in organic solvents. So, we'll say that sodium chloride can easily be dissolved in water, but it can't get dissolved in those compounds which are made of carbon element, because both petrol and kerosene are those compounds which are made of carbon. So again, the same thing. Ionic compounds are going to be soluble in water. They can easily get dissolved in water, but they are insoluble in organic solvent. And lastly, if we talk about the fourth property of ionic compounds, we can say they conduct electricity in molten state or in the solution form. So again, an extremely important statement, students. आप लोग सारी ही properties को one by one note down करो. So here, let's first talk about what is molten state. Molten is basically a scientific term used to express that a material is in melted form. So, if you're using solid sodium chloride or solid magnesium chloride, both the things are uh, not capable enough that they can conduct electricity. But soon they are in melted state or molten state, or if they are dissolved in water, or if they are converted in a solution form, they can easily conduct electricity, which is why in case of electrolysis we use molten ionic compounds. So this was about properties of some ionic compounds. Next topic is about occurrence of metals. See, we have seen that what are the physical properties of metals, what are their chemical properties in terms of what kind of product is formed when they combine with oxygen or water or acid or metal solution. This video is going to be about from where we can get these metals. So, the first thing has been explained over here by saying some metals like gold, silver, and platinum, etc. Always remember gold, silver, and platinum are least reactive elements. We have learned this thing while we were covering about the reactivity series. So these elements are found in the free state in the Earth's crust because they are least reactive. Most metals are found as oxides, carbonates, sulfides, halides, etc. So, this thing should be clear with us that if it is about gold, platinum, or silver, these are going to be there in the free state. Reason being, these are least reactive. But most metals are found as oxides, carbonates, and sulfides, etc. So let's talk about minerals. So minerals are defined by saying that it can either be an element or a compound. So element means occurring alone or in the form of mixture of two or different elements which are called as compounds which occur naturally inside the earth crust. So mineral will be either an element or a compound which will be occurring naturally inside the earth crust. Talking about ore, ore is the place from where uh, ore is again a mineral from which metal can be extracted profitably. And lastly, if we talk about gang, it's the impurities which are there in the ore like rock particles, sand particles, or clay particles. So it's obvious that since these metals are extracted, uh, they are going to have some impurities in there. It can be a rock particle, it can be a sand particle, it can be anything. So these impurities are actually called as gangue. Ore means it's a mineral from where metal can be extracted. And what are mineral? We can say these are elements or compounds which occur naturally inside the earth crust. So this was all about occurrence of metals. Now let's talk about if we have got a metal in the form of oxides, how we can extract these metals from their ores. So, the first statement says that metals are extracted from their ore in three main steps. So, what are these three steps? Number one, concentration of the ore, which is also called as enrichment of the ore. Then we have reduction of the metal, and lastly we have refining, which is called as purification of metal. So students, this is an extremely important topic. So each and every statement that we are covering over here, you people have to note it down in your notebook, so that whenever you people will be preparing for your exams, you people will have these notes with you. So talking about extraction of metal from their ore, three steps are there. So first step, like if we talk about in depth of the first step, it's concentration of ore. So what we can do in concentration of ore, we can basically remove the gangue, which is the impurities from the ore, by different methods. So, one by one, we are going to talk about what are the different methods by which we can remove the impurities from an ore. So, we have our next segment over here, and this next segment here has been named as different steps that are involved in the extraction of metal from their ore. So, ore are basically categorized into three types: metals of high reactivity, metals of medium reactivity, and metals of low reactivity. So, whenever we are getting metals of high reactivity, electrolysis is performed of molten ore. So, when electrolysis will be performed, we'll get the pure metal. Next segment is metals of medium reactivity. So, in case of metals of medium reactivity, we have got carbonate ore and sulfide ore. So, if we are getting a carbonate ore, calcination is the process that we have to perform. On the other hand, if we are getting a sulfide ore, roasting is the thing that we have to perform. So in both the cases, oxides of metal will be obtained, reduction of metal will be done, and then refining. And here we have our last category, which is metals of low reactivity. So we will say that here we'll get sulfide ore. So again, the same thing that we have done in the second case. In case of sulfide ore, roasting is performed, then we get the metal, and at the end of it, refining is done. So if we talk about calcination and roasting, we will say, one second, if we are focusing on calcination and roasting, we can say that calcination is the process in which ore is heated in the absence of air, or when there is a limited supply of air. So here I'm writing it as in the absence of air. Roasting basically means that the process of converting sulfide ore into metal oxides. That's it. So this was about what kind of difference is there Between calcination and roasting, calcination is always carried out when there is a carbonate ore, and roasting is always carried out when there is a sulfide ore. So, moving on to the next segment, which is about extraction of metal low in the activity series. So, the first title here says that metals which are low in the activity series can be reduced to the metals by heating in the presence of oxygen. So, if calcination takes place in the absence of oxygen or when there is very limited amount of oxygen present, we can say calcination is, I'm sorry, roasting is the process where reduction of sulfide ore to metal oxide would be done in the presence of oxygen. Example of this is mercury is obtained from its ore that is called as cinnabar. Hg, that is mercury, and S means sulfur. Therefore, it's a sulfide ore. So, which method will carry out? Obviously, roasting. So, mercury is obtained from its ore cinnabar by heating in the presence of oxygen. So, when it is heated in the presence of oxygen, it will first convert into mercuric oxide. That means a type of C from sulfide ore. When heating is provided, it forms metal oxide. So here we got mercuric oxide, and on further heating, it will reduce to metal. So if we are having mercury sulfide, it will first get converted into mercuric oxide and then into mercury. So the reaction here shows that we had cinnabar, which when combined with oxygen, because we are performing roasting, mercury oxide and oxygen gas is formed. This mercuric oxide on further heating forms mercury metal, and again this reaction will still release some amount of oxygen gas. Same happens with case of uh, extraction of copper. So we'll say copper is obtained from its sulfide ore, that is CuS, by heating in the presence of oxygen. So CuS when combines with oxygen, it forms copper oxide and sulfur dioxide. Then copper oxide combines with Cu2s in order to form copper metal and sulfur dioxide. Okay, so this shows that how we can extract metals which are low in the activity series. They have mentioned examples of mercury as well as, like here in the slide, they basically we have used two examples. One is of mercury and the other one was of copper. Next segment is about extraction of metal which are there in the middle of the activity series. So if I say that uh, metals which are there in the middle of activity series, that means here metals are found in the form of oxides or sulfides or carbonate ore. So we will say that metals in the middle of the activity series like zinc, iron, lead are found as oxide, sulfide or carbonate ore. It's easier to obtain metal from their oxides, because then we simply have to heat it. But it would be a tough thing if we are getting a sulfide ore or a carbonate ore, because then this whole thing might would involve two more steps in order to extract that particular metal. So we will say that so non-oxide ores are converted into oxides. That means sulfide ore and carbonate ore are first converted into oxide form before reduction. Non-oxide ore can be converted into oxide form by roasting or by calcination. Always remember, when there will be a carbonate ore, calcination will be carried out. When there is a sulfide ore, roasting would be carried out. So, talking about roasting, we'll say it's the heating of an ore. Basically, both roasting as well as calcination are all about heating an ore. So, roasting would be done in the presence of oxygen, and this will cause an sulfide ore to convert or to get reduced into oxide form. So, we have ZnS that will combine with oxygen to form zinc oxide and sulfur dioxide. So, that is how we have converted a sulfide ore into metal oxide. Then the next one is calcination. Calcination means it's the heating of an ore in the absence of oxygen. It is used to convert sulfide ore into oxide form. So again, calcination means heating, but in the absence of oxygen. So ZnCO3, that is zinc carbonate, when it is heated, will form zinc oxide and carbon dioxide. This is the reaction that will take place. So the oxide ore is then reduced to the metal by heating with a reducing agent. And the most commonly used reducing agent is the coke, which is carbon. So zinc oxide, when combines with carbon, the both the things are heated over here, and as the product we get the metal, which is zinc and carbon monoxide gas. So that is how we can extract metals which are there in the middle of the activity series. And the processes that we use over here in order to get that metal thing out of ores are roasting in case of sulfide ore and calcination in case of carbonate ore. Now we have our next segment, which is about Thermit reactions. So students, write down your next topic as Thermit reactions. Hmm. So the heading here, I'm sorry, the first statement over here says that sometimes reactive metals, like those metals which are said to be reactive enough, like sodium or calcium or aluminium, etc., are used as reducing agent to obtain metal from their oxides. So we have manganese dioxide, that is MnO2. This MnO2, when combines with aluminium, get reduced to manganese metal, and then it forms aluminium oxide, and this reaction will release some amount of heat as well. So on the basis of this, we can say that reaction between metal oxides and aluminium is highly exothermic reactions. So students, at this point of time, you people should know what is an exothermic reaction. Always remember, exo means out and thermic basically means heat energy. So those reactions where heat energy is given out after the reaction has taken place would be called exothermic reaction. And the metals that are obtained in the molten state because so much of heat is involved. So these type of reactions are called as thermit reactions. Lastly, the reaction between iron oxide and aluminium produces molten iron. This reaction is used to join railway tracks, broken machine parts, etc. So we have got iron oxide combining with aluminium to form iron metal, aluminium oxide, and since it's an highly exothermic reaction, heat will be released. Not a little amount of heat, extreme amount of heat will get evolved. Reason being, it's an exothermic reaction. So this is a picture showing that how we can use reaction of iron oxide with aluminium so that we could join railway tracks because that reaction once again will lead to the formation of aluminium oxide iron metal and at the same time this reaction is exothermic by nature so it will be releasing tremendous amount of heat. Now we have our next segment which is about extraction of metals which are there in the top of the reactivity series. So if we talk about metals which are there in the top of the reactivity series, we have sodium, potassium, calcium, aluminium, etc. So these can't be obtained from their ores by simple heating or by using reducing agent. So this is the time where we have to do electrolytic reduction of their molten chlorides, or we can say this is the time where we have to perform electrolysis, where with the help of electricity we will be reducing these molten chlorides into their pure form. Example is when electric current is passed through sodium chloride. What type of sodium chloride it should be? It should be in molten form. That means it should be in melted form. And if sodium chloride is going to be in melted form, it will have free sodium and chlorine ions. So sodium metal will get deposited at cathode while chlorine gas is deposited at the anode. So cathode means the electrode which is going to have negative charge. Anode means electrode that is going to have positive charge. So science क्या कहती है? वो चीज जो positive charge carry करेगी, that means sodium obviously attract होगी towards something that is negatively charged and then chlorine के साथ क्या होगा? Since it is carrying negative charge, it will get attracted towards one such thing that is carrying an opposite charge, that is positive charge. So that is how sodium will get attracted towards cathode and chlorine ion will get attracted towards anode. So इस attraction की वजह से क्या होगा? That since यहाँ पर free electrons होने वाले हैं, cathode में sodium ion, since it is just carrying one single electron, one single positive charge, this will combine with an electron to form sodium metal. On the other hand, at anode, this chlorine ion, since its quantity is 2, it will release or lose 2 electrons to form chlorine gas. So that is how we can get metal with the help of electrolytic reduction of their molten chlorides. Here we have our next topic, which is about electrolytic refining. So, if we talk about electrolytic, it's about refining of metal, which is also called as electrolytic refining. So, the first statement here says that the removal of impurities, like why refining is mandatory? Refining is mandatory because the removal of impurities from the metal is essential, because that is how we can obtain pure metal, right? So we will say that the process by which impurities are removed from a metal so that we could get a pure metal is the refining of metal. The most common method for refining of metal is electrolytic refining. That means with the help of electricity, we are going to remove all the impurities so that we could get pure metal. So here we can say in this method, a block of impure metal is made, the anode, and a thin sheet of pure metal is made the cathode. An electrolyte is a salt solution of the metal to be purified. Example, in the electrolytic refining of copper, a block of impure copper is made has made the anode. A thin sheet of pure copper has made the cathode. So the electrolyte is acidified copper sulfate solution. When electric current is passed through the electrolyte, pure copper from the anode is deposited at the cathode and the impurities settle down as anode mud. So that is how we can get pure metal after removing all the impurities. Moving on to the next segment, which is about corrosion. So, corrosion is not applicable to all the metals. There are few metals which uh, are majorly affected by corrosion. So we will say that corrosion, I'm sorry, will say that corrosion is basically the damage which is caused to metals due to reaction of metal with oxygen, moisture or carbon dioxide gas. Example of this could be formation of brown coating of rust over iron. So आप क्या करो, अगर एक आयरन नेल को भी हम बाहर रख दें, let's just say rainy season में, so you people will notice that after like a month or so, that the outer surface of that iron nail will have this brownish coating, and this is all because of corrosion. Then we have formation of green coating of basic copper carbonate over copper. Last one is formation of black coating of silver sulfide over silver. So these were three examples of corrosion. So we are going to perform one experiment just to show that air and moisture are necessary for the rusting of iron. So what is rusting? Again, an example of corrosion. So for that, we are going to take three test tubes. We'll name them as 1, 2, and 3. And in all the three test tubes, we will put iron nails. But some no, and then we'll put some anhydrous calcium chloride in test tube 1. Why we are putting anhydrous calcium chloride? Because it's that compound which absorbs all the moisture content. Then we'll pour some boiled distilled water in test tube 2 and pour some oil over it to prevent air into the test tube. Lastly, pour some water in test tube 3. Cork the test tubes and leave them for few days. So क्या किया है हमने, अगर आप इस डायग्राम में स्टूडेंट्स केयरफुली देखो, फर्स्ट टेस्ट ट्यूब में वी हैव प्लेस्ड एन आयरन नेल यानी कि कील, और वी हैव प्लेस्ड कंपाउंड कैल्शियम क्लोराइड, एनहाइड्रस कैल्शियम क्लोराइड, बिकॉज ये मॉइस्चर को एब्जॉर्ब करता है. सेकेंड में वी हैव जस्ट प्लेस्ड डिस्टिल्ड वाटर आयरन नेल डालने के बाद, और ऊपर में थोड़ा सा तेल डाला है सो दैट एयर शुड नॉट एंटर इनटू द टेस्ट ट्यूब. एंड देन इन द थर्ड टेस्ट ट्यूब हमने अगेन वाटर डाला है आफ्टर पुटिंग द नेल. And then we have placed 3 corks, and after leaving these test tubes for like few days, we will see that the nails in the test tube 1 does not get rusted because it had only air but no water. And for corrosion to occur or for rusting to take place, moisture is the main thing. Nail in test tube 2 does not rust because it only had water but no air. And then nail in test tube 3 gets rusted because it has both the things, air as well as water. So now we know that air combined with water promotes corrosion or rusting. If just one of the factor is present, then there will be no corrosion or rusting. Moving on, let's talk about how we can prevent corrosion, because if corrosion is taking place some or the other way, it is going to affect properties of metals. So let's just learn about how we can prevent corrosion. So we have our first statement, which is like corrosion of metals can be prevented by applying oil or grease, application of paint, because जैसे हम कोई भी चीज अप्लाई करेंगे basically it will form a protective layer, and that's how both air and moisture won't be able to combine together in order to cause corrosion or to cause rusting. By galvanization, which is coating the outer surface of a metal with zinc. By tinning, that means coating the outer surface of metal with tin. By electroplating, that is coating a less reactive metal like chromium. And by alloying, that means by making alloy. So this was all about corrosion and how we can prevent corrosion. Now let's talk about what is an alloy, because in this chapter we have learned so many things regarding metals and non-metals, but we haven't talked about what is an alloy. So we will define alloy by saying that an alloy is an homogeneous mixture of a metal with other metal or a non-metal. For example, स्टील कैसे बनता है? स्टील इज मेड अप ऑफ आयरन कंबाइनिंग विथ कार्बन. स्टेनलेस स्टील में 4 चीजें होती हैं, दीज आर we have iron, carbon, cobalt and nickel. So whenever there will be a mixture of a metal with another metal, या फिर whenever there is a mixture of metal with a non-metal, these all are very good examples of alloys. So this was about alloy with some of their examples. And students, with this, we have covered all the topics which were there in chapter 3 of your science book. I hope ये videos आपके लिए helpful हैं. आप लोग जब भी इन videos को देख रहे हैं students, make sure करिए कि आप लोग सारे statements note down करें, सो दैट जब आप लोग अपने एग्जाम्स के लिए प्रिपेयर करेंगे तो आप लोगों के पास एक थरो नोट्स होंगे. एंड देन अगर आप लोगों को कोई भी डाउट है या फिर आप लोगों को लगता है दैट कोई भी टॉपिक फिर से रिपीट होना चाहिए क्योंकि आप लोगों को अच्छे से समझ नहीं आया, मेंशन द सेम थिंग इन द कमेंट सेक्शन एंड देन विल ट्राई टू फुलफिल योर नीड्स. सो थैंक यू.